When you are ready to begin the presentation, press the Start Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Good morning to everyone. Nagarjuna from Surya Hana Academy. So we're going to start today's session. So before that, I would like to recap yesterday's session. Hope everyone is able to hear my voice without any breaks, without breaking in between. Can everyone please confirm with me if it is possible? Thank you. Thank you so much. So to start again, what is a calculation view? Calculation views data sources. For a calculation view, data sources, attributes, analytics, analytic view, calculation view, and tables. Different operators inside a calculation view. Join, query based on a condition. Union, to combine the results. Aggregation, how we would like to summarize a measure. Projection, a selection of columns, or to filter data, or to create calculated columns. And rank, to rank data. There are different data categories inside a calculation view. Number 1, dimension. 2, cube with star join. 3, cube. Yesterday, we have seen the difference between these three of these data categories. So when do we have to go for dimension? When we deal with master data tables. Calculation views of type dimension are the replacements for attribute views because attribute views cannot be used inside cube with star join because cube with star join executes on an SQL engine. SQL engine doesn't permit to use attribute views. So instead using attribute views, we use calculation views of type dimension to provide master data to cube with star join. So we know whenever we execute cube with star join, it doesn't permit attribute views. For dimension modeling, there are two objects. One is an attribute view, the other one is a calculation view. So today, first I'm going to start with how we would start creating a dimension model for a calculation view. So I log into HANA Studio, click on Start, click on SAP HANA Studio, click OK. Double click on the system. Username is best, password is welcome123. Expand. Hope all the participants have received system access. Hope everyone is able to log into HANA system. And please let me know if any of the participants haven't received any details. So I'll make sure that I can follow up with the server team and get things done. But please kindly email me to nagarjuna.k@gmail.com or server.suryaacademy@gmail.com. If anyone having any issue, please do email me so I can basically follow up and get things done. Thank you. So we have catalog and content. Once we log into HANA system, we have catalog and content. Once we expand, content, so here we see ECC March 7:30 a.m. So yesterday I created few data models for you to practice. So these are the data models a few of the data models we have created, and these are the old ones. So today I'm going to create calculation view of type dimension. So this is the yesterday's one. I'll just delete this. So what I'm going to do now, please see we created AT customer. I'll double click on AT customer. And we know we have done this exercise in past. For customer. So I'm going to do the same thing again. I'm going to repeat the same thing, but this time I'm going to do for calculation view. Right click on the package, click new, and click on the calculation view. So create an information view, select the required view type, and enter the details. I'll give as CV underscore customer and provide the label. CV customer, the label is customer. View type is a calculation view. View type is a calculation view. Subtype is standard. Calculation view type graphical. And data category is a dimension model. If you set the data category as a dimension, the default node is a projection. And click finish. So here we have semantics, and under semantics we have projection. So whenever we take a calculation view of type dimension, the default node is a projection. So click join, click on the join, and click on the work area. So these are known as simple joins. Now what is the difference between a simple join and a complex join? You see, even in an attribute view, when we create AT customer or company code, so this is where you can create complex joins. So when we say in a calculation view, please see what is, if I click on the semantics, click on the view properties, please see what is the data category. The data category is a dimension. So the calculation view data category is a dimension. Now, when I double click on AT customer, click on semantics, click on view properties. In here also the data category is a dimension. So for data category dimensions, you can create attribute views, we can create calculation views. Now, when we say a simple join, it means that we cannot take more than 2 tables. But in my requirement, I have 3 tables. So first what I'm going to do is join underscore 1. In join underscore 1, I'll click on the plus icon, add the table KNA1. So please take KNA1 from best schema, because for the best schema we have full authorizations. We have full privilege to access any tables from this schema. So I'll select KNA1 from best, click OK, and then let's click on the plus icon again, enter the table name T005T, click OK. So once I've taken two tables, once we have taken two tables, is this okay? I mean, someone is saying my voice is breaking. Some of the participant, is my voice clear or hello? Okay. I think it's an issue from your side. Please kindly check from your side. Okay, I'll just continue. So in join underscore one, we have two tables. Now, when I enter the first table, I enter the second table. Now, do we see the plus icon over here? We don't see. The plus icon disappears. It means that in a simple join, you can add only two tables. So in join underscore one, you see, the things that I'm actually doing is same again. There's no difference between the relationship between tables. The relationship between tables, output, the data that is given on the output, everything is same. But the engine that process this view is different. Attribute views process on join engine. Calculation views of type dimension are executed on a special engine called SQL engine. So there it is on a join engine. In here, the same output is processed in the engine that is SQL engine. So I'm going to do the same thing, defining relationships, taking output, everything would be same, but I'm creating this in a calculation view. So in join underscore one, I'll join land1 to land1, and then KUNNR, land1, name1, regio, the same thing, regio, and then we take landx to the output. Select the join type is a text join. The language column is SPRAS. Now click on this join. Now these are the output columns. I need to add I need to add third table. Click on the join again. Click on the join on the work area. Link join 1 to join 2. Join 1 provide data source to join 2. Join 1 is a data source to join 2. Join 1, I'll right click, I'll add the table T005View from best schema and click OK. So now join land1 to land1, regio to bland. So KUNNR, land1, name1, regio, landx, and BEJDI. So the join here again is a text join. SPRS. So join 1 data source to join 2. Join underscore 1 I join with T005U. I've taken required output. Link join underscore 2 to projection. Click on the projection. select required column for the output, click on the semantics, at least one key attribute, provide label mapping, descriptive mapping, hide text columns, validate, save and activate. Excuse me. So expand the calculation view, right click on CV customer, click data preview, click raw data. Now we can add filter on KUNNR, add filter on KUNNR, click show list of values. I just try to increase the maximum value, refresh, enter the value, and select 2. Just trying to show you the same output on 2. I selected 2, click OK, click execute the filter, click execute. After filtering, execute. And here we see, do you see the same output as an attribute view? 02 wet, D Germany, 08 Baden. But the output that we are seeing over here, I can click on show log, double click on generated SQL. So I'll copy the statement, open in the notepad. So here we can see _sys_bic. This is the package and this is the CV customer is the view, where KUNNR is equal to this one. So I'll just copy the column view. I'll copy the column view, close and close. I'll expand catalog. I'll expand the catalog. I'll go to the schema _sys_bic. Expand BIC. Expand column views. These are all the different column views. I'll right click on the column views, click filters, copy paste the column view. Column view is nothing but the runtime view when we generate the information views. Click on whole word, click OK. So here we see the calculation view of type dimension. Double click on this view, columns. So these are the columns. Create statement. Excuse me. So this is the statement that system has generated. Based on the column view, this is the code that system generated in the backend. So we cannot edit this code. So what I'm trying to show you is whatever the code that we see over here, which is SQL script, all this SQL script. So if I click on the free space, just click on any of the join and then click on the free space. Then we can see the properties of the view, properties of the information view, which is CV customer. Now we know we discuss a calculation view by default executes on a column engine. That is a calculation engine. A column engine is the calculation engine. But we can execute the same view, we can execute the same CV customer, execute in an engine called SQL engine. So by default, calculation view executes on a calculation engine. but we can make it to execute by choosing the option execute in SQL engine. View is same, but only the engine that is executed is different. So output of an attribute view is same, output of a calculation view is same, but engine that is actually processing these views are different. So I'll validate and activate again after changing the property. We don't see much difference in the code or the way the model is generated, but only we can see from the performance point of view, it is faster. I'll just give a small example. Whenever we play video games, you see suddenly there is this small button called boost or something. When you just click on that button, suddenly the car moves faster. The same way, this is the button. So when you actually execute an SQL engine, simply the view is executed faster when you use SQL engine. But what is the limitation of an SQL? There is a limitation. The limitation is we cannot use attribute views inside the SQL engine. And attribute views cannot be used, even analytic views cannot be used. So if we cannot use attribute views, then how to design the dimension models? We have to design calculation views of type dimension in this fashion. So I'm going to create one more view to get the complete scenario. To get the complete scenario, I'm going to create one more view. Right click on the calculation view again, click new, CV underscore company code, CV underscore company code, label is the company code, data category is the dimension. Data category is the dimension, and click finish. So once we click finish, I'll click on the join again, click on the work area, join underscore 1, click on the plus icon, add objects, add the tables T001 from best. I'll add one more table TVKO from best. So first I'll complete this. T001 and TVKO. BUKRS to BUKRS. Text join. I'm sorry. It's inner join. Click on join again. Let us choose field selection for output. BUKRS, BU text, VKORG, link join 1 to join 2. Click on join 2. Add table, and the plus icon. Add the plus icon and add TVKOT from best. Click OK. So I'll join VKORG to VKORG, VKORG to VKORG. Join type is a text join. Language SPRAS. BUKRS, BU text, VKORG, and VText. And join is the text join. So I completed the second one. I join 1 to TVKOT. The next one again, let's click on join again, and let's click on the join again. So in here, I link join 2 to join 3. Join 2 to join 3. And in the join 3, I'll add the table TCURT from best schema. Click OK. So here we see join 2 and join 3. Here we see join 2 and join 3, join 2 and join 3. We link with WAERS, but here we don't see WAERS. Okay. In case, let's say, it is common sometimes we may forget some columns during performing any of the data models. So, for example, let's say you wanted to add a column in join 1, but already you are in join 6 or join 7. Again, to go to the bottom, add in every join is difficult. So for this, SAP has provided one option called go to join 1, go to join 1. So here I have done wrong mapping. We have to map to BUKRS. So I'll go to the join 1. I'll click WAERS. Please see, I'll click WAERS. Now please see, I don't have in join 2 or in join 3. So what I can do is, I can select this column, right click on the column, and you can say propagate to semantics. When you say propagate to semantics, you're adding this column in join 1. Whatever the middle layer objects are there, it'll directly go to the semantics. So I'll click propagate to semantics. So element WARS propagate to join 2, WARS propagate to join 3, and click OK. So suppose say if you forget any columns, we can do propagate to semantics. So let's click on join 3. Let's click on join 3 and join WAERS with WAERS. I'll select the other columns which are required for output. I'll select the join type as text join. I'll select the join type as text join. And then we'll select ltext, currency text, join 3 to projection. Because we already know all these relationships, so I'm moving faster over here. And then we want all the columns for output. Right click on join 3 and add all to output. Add all to output. And finally click on semantics. You have all the columns that are required. And now let us click on this icon, auto layout. Automatically it will excuse me, automatically it adjusts the model. Finally click on semantics. Click on the semantics. The key attribute is BUKRS. I'll take to the top. So label BU text, WARS, ltext, VKORG, VText, and hide the remaining columns. Click validate and save and activate. Now can we check the things that we have done for CV company code is correct or not? So I'll right click on the CV company code, and click data preview. I'll click raw data. I'll add filter. BUKRS. Click on show list of values. Select 1000, a selected value, and click OK and click execute. So please see its output is same. Remember, for an attribute view, when we done this exercise, 7 rows for output for company code Germany, and these are the different sales organizations, and this is the currency in which the company code operates. Now, excuse me. Until now, we created a star join. Sorry, we created dimensions for star join. We created dimensions for star join. So this is a calculation view. This is C. You can make to execute an SQL engine. And this one is an analytic engine, which is OLAP engine. I'm just trying to draw this diagram. VV010001, VV070001. So I'll just try to adjust this here. Okay, so now we're creating dimension for star join, that is for calculation view. So this one is a calculation view of type cube with star join. So these are two different data models. So here we have calculation view cube with star join, and in here we have dimensions for analytic view, which are nothing but the attribute views. So when we're creating an analytic view, and executing an OLAP engine, we're creating calculation view of type star join. By default, it executes in CE engine, but I can make to execute on the SQL engine by changing the properties. In here, attribute views provide master data to the analytic views, but here calculation views of type dimension provides master data to cube with star join. In here you can have multiple fact tables. But in here you can have a single fact table. When you have multiple fact tables, this is also called as snowflake schema. Snowflake schema means requesting measures from multiple fact tables. Now this is known as star schema. Star schema. You can have only a single fact table, but here you can create based on multiple fact tables. You see, I have measures from both actual as well as I have plan. So this enables me to create snowflake schema measures from multiple fact tables. Now, when should I go for this, and when should we go for this? Now, how can I achieve the same kind of scenario in an analytic view? Is it possible for me to achieve in an analytic view requesting data from multiple fact tables? No, I cannot achieve. But I can achieve this indirectly. How I can achieve this is, now for example, we'll take two tables. I'm trying to explain one point over here. The point here is, when should we create cube with star join, and when should we go for analytic views? So here, let us consider we have two tables. Both these tables are on the OLTP system. Both these tables are on OLTP, Online Transaction Processing System. So here you have CE1 table, and here we have CE2 table. Now, when creating analytic views, either I can use CE1 inside, or I can use CE2. Or what is the other way I can do? I can merge both these tables together. And create a single output table wherein I can have measures from both these two tables into a single table. So when I have a single table, based on the single table, can I use this in the analytic view? Yes. So what are we trying to do here? These tables are normalized tables. I'm trying to denormalize them and put in one single table. Instead of two tables, I'm merging both these tables and keep this in one single table. And based on this table, I'm creating an analytic view. But when you're trying to merge both these tables, where are we doing this? In the ETL process. In the ETL, you're extracting these tables, you're transforming them according to your business needs, and finally load them to Hana. ETL, extract, transform, and load. You extract data from these tables, you transform them to the desired output, and finally load to Hana. Then now if I have a table like this which is already transformed to my business needs, now can I use a single table like this in a single analytic view? Okay, this is possible because you have a sidecar scenario. In a sidecar scenario, you'll have ECC over here, you'll have BODS, yeah, BODS. Anyways, we require to move data to HANA. So ECC to BODS, BODS to HANA. The tables are here, both the tables are here. Trying to take both these tables to BODS. BODS is an ETL tool. BODS is an ETL tool. From ETL tool, you're transforming data to desired output and finally load to HANA. In HANA, you're creating this data model. And this data model executes on OLAP engine. So this is a sidecar. Now, let us see this one. On the main car, you have ECC over here. You have ECC. Underneath the ECC system, we have HANA system. Means ECC powered by HANA. ECC powered by HANA. So, what does this mean? If I have like this, where can I denormalize tables? The tables are directly in HANA. It means that I have two tables now. In HANA system, I have two tables, same table, CE1 and CE2. I have CE1 and CE2. Now, what is my requirement over here? My requirement is when I have ECC on HANA, both CE1 and CE2 should produce a desired output of having measures in a single table. Now, yes, we can do snowflake schema. We can create snowflake schema using cube with star join. But if we see, originally when calculation views are developed, they were kept in mind. To execute complex calculations. That is what the C engine does. Now, what is C engine very, very good for? It is good and optimized for executing complex calculations. On the other hand, what is the other need over here? Not only complex calculations, but we are using operators like, we are using operators like joins, unions, projections, aggregations. We are using different kinds of operators. Like when you do a join, what kind of complex calculations can we create? Probably when I click on join 1, here you can create calculated columns or calculated attributes. Now in this case, I even don't have calculated attributes over here. In join 1, I can create calculated attributes. So the point I'm trying to highlight over here is whenever we create normalized data models, means data models, OLTP systems, transaction processing systems on HANA, not only the engines should be optimized for complex calculations, these engines also should be optimized for better join determination technique. They should have a capability of joining in a very efficient way and produce the results very efficiently. So they have to balance between joins and aggregations of data, because data is distributed across several tables. Now we would like to use all the required tables and create data model. So in order to execute these data models efficiently, SAP introduced a new engine called SQL engine in the service pack SP8. To exploit that engine, apart from the calculation engine that we used to have, they introduced a new engine called SQL engine. In order to exploit that engine capabilities, we cannot use attribute views. Please see. I'll go back to HANA Studio. I'll right click on the calculation view again. Click New. I'll create a view CV underscore COPA underscore actual underscore plan underscore data. I'm creating the data model in which I have actual as well as plan in the same information view. I'll take the data category as cube with star join. If you set the data category as a cube, the default node is an aggregation. If you change the default node to star join by selecting the checkbox. So if you don't check this, it becomes a cube. So when you take cube, what is the default node? Aggregation. What is aggregation? How you would like to summarize the measures. Now when you check this, it becomes star join. So this is nothing but the star join. A star join can contain multiple fact tables to create a snowflake schema. To create these kind of models, what is not permitted is attribute views are not permitted as dimensions. So let us go back. Now I'll click finish. So what is the default node? The star join. When you take projection, what is the default node? Sorry, when you take dimension, what is the default node? Projection. When you take star join, default node, star join. When we take cube, default node, aggregation. So for a cube, it is aggregation. For dimension, it is projection. For a cube with star join, the default node is a star join. I just want to show, excuse me. I just want to show this limitation. So I'll select AT company code. I'll drag and drop this AT company code inside the star join. Please see, does it allow? It says it cannot allow. It doesn't allow inside the star join. So what I have to do? Because it doesn't allow, it means that I have to take CV company code. Both output are same. So I'll select this. Does it allow? Yes, it allows. Why does it allow calculation views of type dimension? Because that is a limitation of the star join. Because it executes on a special engine called SQL engine. SQL engine is not capable of processing attribute views which were originally designed to execute on join engine. And join engine is optimized to process complex joins, but calculation views of type dimensions are optimized to process simple joins. That's why you see when processing this, when we're designing these data models, we actually taken simple joins to process two tables at a point of time. So I'll go back again. So here I've taken CV company code and CV customer as two of the dimensions. Still the scenario is not complete. I just create two dimensions, but I would also like to create few more dimensions and start creating the start join. Excuse me. So I'll recap today's session, what we have seen in today's session. In today's session, we started to see the difference between calculation views, data category, dimension, cube with start join, and cube. Still we haven't seen cube. We are still at the cube with start join. So because I would like to create cube with start join, I started to create calculation views of type dimension. Dimension data modeling can be achieved using attribute views, can be achieved using calculation views of type dimension. Attribute views, attribute views are used inside an analytic view. Analytic view limitation is only to process single fact tables. It processes on OLAP. OLAP optimized to process parallel processing, mass aggregation of data. Limitation on single table. Now this can be achieved because whenever you have ECC on a sidecar scenario, you can achieve using ETL the desired output. And even for the same requirement, we can create an analytic view. But how about when you have ECC on Hana? When you have ECC tables in Hana, we're not doing any denormalization. We want to create data models for operational reporting, for operations. Because ECC itself is on HANA. So this is an operational reporting. And these are similar to data warehousing solutions. This is ECC powered by HANA. So when we're creating data models for operational reporting on a normalized tables, where we expect decent performance for these views, the performance of a calculation engine, customer complain, especially when designing data models for normalized, the calculation engine was not efficient to process these data models. And SAP then introduced a new engine in SP8 which is known as SQL engine. Where an SQL engine does better join determination technique and executes the view faster. How faster it can execute? 50 times faster than the calculation engine. So we create a calculation view of type cubes. We create calculation views of type cube with start join. We can use the normalized tables inside the start join because it does allow requesting measures from two or more fact tables. I cannot use attribute views inside cube with start join. That's a limitation because SQL engine doesn't process. So I created calculation views of type dimension and taken as a dimensions. So once we complete tomorrow this data model, first we see execution on a C engine, then we see execution on an SQL engine, then we see performance. And then we will see what data model should be created on what engine and the internal processing, how these data models are processed internally using visualize plan, explain plan. You can see the performance of each of them in a graphical representation that is using visualize plan and explain plan. Thank you everyone to attend today's session. If you have any questions, please type in your chat box or please raise your hands. We can discuss. Thank you. So I'll read out the questions some of the participants, attendees have sent in the chat box. How to unselect all if by mistake all the attributes are being selected to show in the output. Okay. So what we can do here is we can go to HANA Studio. For example, for example, if you go to this view called company code, suppose say by mistake I say add all to output, then you see all the columns which I don't require also in output. So what I can do is I can just right click, remove, or you can just select these columns that you shift, select, right click, and deselect all. I'm sorry. I can delete. Okay, I can just delete from here. Probably I'm not able to do from here. And just select this, right click and remove. And click yes. So all of them got deselected. If you want to do on a single column, we have deselect all, but on a single column we don't have. In that case, what we can do is just, you see this orange color, click on the same icon again. Click on the same icon again. Automatically it will say you want to remove. Yes. Click OK. Single columns you can just deselect it. Click on the same icon. Or for bulk columns, just select everything, right click, remove. Click yes. Let us see next question. To get, do we get entire data in raw data even if we put filters in the data foundation in any view? No, we will not get. For example, I go to company code, I go to this view, I create a design time filter on the company code, apply filter, show list of values, select 1000, click OK and OK, and then validate activate, and now completed successfully. Now I data preview, click raw data. Now if you want to still check, you can click on distinct values, click BU KRS, please see, only 1000. So means the output of the view itself is restricted because the restriction is done before even executing the join condition. So even when you see raw data, it will only show the desired output for which we have filtered. So let us see the next question. Where can I find the tables TSPA, TSPAT, TCURT, T006, T006A? So basically, if you want these tables, I can basically do a quick load for you. You want those particular tables, what I can do? I'll do it very quickly. I'll go to Data Services Workbench. So this is we'll see as a part of data provisioning, but just because you need them, I'll do it quickly. So let's enter to Data Services Workbench, and then double click on ECC, and here you have these tables. I'll remove them. So I'll again double click on ECC tables. Anyway, we'll see this again, but just TSPA, TSPAT. TSPA, TSPAT, TCURC, 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 T006, T006A. Once we get all the required tables, now I'll select the required tables for the output. So we require T006, TCURC, TSPA, TSPAT. So select, drag and drop, execute, validate, execute this. Click yes and click finish. So I can do this via data provisioning using Data Services Workbench, but we will see once we complete data modeling, probably after this week, in the next week, starting of the next week, we will see in more detailedly. So now I got all these tables. So I'll go to Hana. Now I'll go to the content. I'll go to the schema. I'll expand the tables. Now here you can see these tables. I click on tables, refresh. You can see TSPA, TSPAT, TCURC, TCURT, T006A. And I click data preview. So here we can see. Okay, then these are the questions I have in the chat box. Thank you everyone to attend today's session. We will see you tomorrow same time. Have a good morning to everyone. Good evening and good night. Thank you. Just there is some question I think here. Yes, please. So in join one, how many tables can we join? Only two tables. We can join two tables. So in join one, how many tables can we join? We can join two tables. Next, you selected BUKRS as a key attribute. This means primary key. If it is a primary key, then the value should be unique. How come it is accepted rows with the same 1000? And here you see, when we actually see BUKRS is a primary key, but we are executing the inner join condition. So when we're executing the inner join condition, for different sales organizations, you have different sales, I mean you have 7 sales organizations. So what it is trying to do is, based on the join condition, which is an inner join, it gets the common values and displays in 7 rows. There is only one company code, but the same company code is actually repeating multiple times in an output because we are executing an inner join. Because there are 7 sales organizations. Now if you have 10, it will show as 10. If you have 1, it will show 1. Because the condition is the inner join. Yeah. So right, but in the output you selected BUKRS as a key attribute. If we selected BUKRS as a key attribute, the reason is later we would like to join the same key attribute to the fact table. So in here it is a key, but in the fact table it is a foreign key. So any other questions? Any other questions anyone have? Okay, thank you. I'll see you tomorrow, same time. Thank you.